Is there any way science can stop crime? I'm David Pogue, and on this episode of Nova Science Now, we are tracking down cutting-edge research in the world of crime fighting. Are killers born or made?
These stories started to proliferate that there was something really wrong in our family.
Are some people more prone to violence than others?
What is the warrior gene, and what is its relationship to aggression?
There are some men that are biologically speaking much more likely to be violent and aggressive than others.
We're peering inside the criminal mind.
Environments can change the way that your brain is wired.
And
Captain, I sense a disturbance in the tri-delta vector.
with new technology, can we sense lies in the brain before they're even spoken?
In about 200 more milliseconds, he's going to be ready to lie.
You got to the point where you could know whether I was lying or not.
Yes.
That's freaky.
And can scientists help investigators determine when a victim died?
So timing is really crucial.
How do you even estimate? Here, I'll show you. Isn't this usually reserved for less animated people? Typically.
Their discoveries may shock you.
3 days? But how could that be?
That's what we're going to try to find out.
Can science stop crime? Up next on Nova Science Now.
Funding for Nova Science Now is provided by the National Science Foundation, where discoveries begin, and
discovering new knowledge, biomedical research and science education, Howard Hughes Medical Institute, HHMI,
and the Alfred P. Sloan Foundation, supporting original research and public understanding of science, technology, engineering, and mathematics, and the George D. Smith Fund. And by PBS viewers like you. Thank you.
I'm David Pogue, host of Nova Science Now by day, and by night, a Caped Crusader on a mission to fight crime. Okay, not really.
I had no idea that getting a perm was such a complex operation these days.
But I am on a mission to find out if science can stop crime.
Is this an eBay hair salon purchase here?
But this isn't all fun and games. We hear about violence in the news all the time.
In an especially brutal attack on a teenager.
Confessed to killing 33 boys.
Now, scientists are trying to find out if there's something different about the criminal mind.
I looked at it and I said, it's obviously murder, but it was me.
Are violent brains created by nature?
There goes my spleen.
Or nurture?
Power both hands, power both hands. Stop.
I'm in San Francisco learning how to fight. My trainer is a former gang member and mixed martial arts champion, Eugene the Wolf Jackson.
Don't act like you was an AP student. Good. Yeah. We got the warm-up out the way.
Jackson teaches teens to stay off the streets by taking their aggressions out in the ring. One of Jackson's most promising fighters is his own son, Nico. In the ring, Nico is a feared fighter, the top of his division after only 2 years of training.
It's me versus you. Who's the better man? Like, only one of us is going to walk out with our hand raised, and I love that.
Oh my God! That's so loud! He was cutting up his blood.
But as a young teen, Nico's urge to fight got out of control.
In my first year of high school, I started straying down the wrong path.
He got caught up with the notorious Taliban gang.
Local, county, state, and federal agencies teamed up to target these violent gang members they say are responsible for murders, assaults.
We all know people who seem more violent than others, with shorter tempers and less self-control. What causes aggressive behavior? Is it their upbringing? Is something wrong with their brains? And most controversial of all, could violence be in their genes?
there's obviously some aggression on display here.
Right.
Criminologist Kevin Beaver analyzed the genetic profiles of more than 1,000 young men and examined their criminal records, and says he found a pattern.
There are some men that are biologically and genetically speaking much more likely to be predisposed to be violent and aggressive than others.
If that's true, is it possible that Nico is one of them? Nico's DNA has been analyzed, and he carries a controversial gene that, according to some reports, has been linked to violence. It's been nicknamed the warrior gene.
I try to avoid problems as much as possible, but I have a limit when reached that I just flip out, red line a little bit.
Is it really possible for one gene to have that kind of impact? It turns out the so-called warrior gene is actually one version of a very important gene called MAOA. The gene works in the brain, helping to control chemicals called neurotransmitters that allow brain cells to communicate with each other.
What that gene is responsible for doing is regulating levels of neurotransmitters. These chemicals are responsible for our behaviors and our traits and things of that nature.
All of us have the MAOA gene, but about 1/3 of men carry a version that's less active and may leave more neurotransmitters floating around in our brains. So what's the result? Well, we know what happens in mice. Scientists at the University of Southern California engineered these mice to have a totally dysfunctional version of the gene, and their personalities are obviously transformed.
When you do this in mice, you see that they become incredibly aggressive. These are the mice who are much more prone to biting and scratching and attacking. Very straightforward, very simple task.
But what happens in people? Neuroscientist Joshua Buchholz is one of the researchers now trying to unravel the relationship between this gene and violent behavior. He's found evidence that it can affect some key circuitry for emotion and learning in our brains.
Let me tell you a story.
To understand how this circuitry is supposed to work, Buchholz told me a little story.
Imagine that you're walking through the forest one day. You look down and you see a snake.
Oh, snake! Snake!
At that moment, a part of my brain that's primed to detect threats, called the amygdala, starts firing on all cylinders.
The amygdala is like an alarm bell. It's really important for telling the rest of your body that something important is happening in the world and you need to prepare for it. And your heart starts beating and your pulse starts racing and you start sweating.
But just as I'm starting to freak out, I take a closer look.
And then you look down again and you see that it's not a snake, it's actually a stick.
Oh.
And you feel your heart start calming down and your pulse isn't racing so much. You get some new information, you update.
I'm able to update because a learning part of my brain in the prefrontal cortex sends a message to my amygdala to shut off the alarm.
And that sends inputs back down to the amygdala that says, cool it, relax, we're okay. And you don't even feel anxious anymore.
At least that's what's supposed to happen.
Let's get you into the scanner.
But when Buchholz looked at the brains of people with the controversial version of MAOA, this part of the brain looked different.
What we found was that the people show less gray matter in parts of the brain that are involved in this circuit we've been talking about.
They have less gray matter?
That's right. They have less gray matter than the people who have the other version of the gene.
Not only did they have less gray matter, but when they were processing emotions, Buchholz found their amygdalas were more active. So would that make them more violent?
Well, no. I mean, this is the really interesting thing. All of these people who we brought into our lab are just normal community volunteers. These are not violent people. These are not psychopaths. These are not criminals. And what that tells us is that one single factor acting alone isn't enough to make someone violent.
So even though about 1/3 of men, including Nico, have the so-called warrior gene, that doesn't make them aggressive. The creation of a truly dangerous mind is far more mysterious than a single gene. DNA is just one piece of the puzzle.
Oh, there goes my spleen.
So what are the other pieces? Wow. Few people have pondered this mystery more than neuroscientist James Fallon. Fallon has spent more than a decade studying the brains of violent killers. But a few years ago, his work took an unexpectedly personal turn when he discovered that his own family has a lot of blood on its hands.
These stories started to proliferate that there was something really wrong in our family.
The Fallon clan includes nearly a dozen murderers, spanning more than 3 centuries. Suspected axe killer Lizzie Borden was a cousin.
That's not cheating, it's gamesmanship.
Curious, Fallon had his immediate family tested for the so-called warrior gene. And it turns out that he, his mother, his wife, and their son James all have it. Next, Fallon investigated a collection of brain scans he'd gathered while working as a consultant on criminal trials. Compared to non-criminal brains, the murderer's scans appeared to show abnormal circuitry in the emotional part of the brain. When Fallon had his own brain scanned, the results shocked him.
I looked at it and I said, this is in the wrong pile. It's obviously a murderer, but it was me.
Of course, it's actually impossible to ID a murderer based on a single scan. But Fallon saw a pattern of activity that suggested that he had the same unusual brain wiring as the criminals.
It was disorienting, but it was like, oh, I got the joke. The joke is on me. I've been studying this stuff, and I got the pattern.
Still, Fallon might be an aggressive Scrabble player, but he is not violent. The question is, why not? Fallon himself believes he was biologically at high risk for a violent life, but that those negative factors were trumped by an overwhelmingly positive childhood.
I was really loved like a golden child, and it must have just negated the effect of all these other violence-related genes and everything.
But could environment really counteract the negative effects of high-risk genes and brain structure? And what really goes on in a violent mind? Scientists at Brookhaven National Laboratory are trying to answer just these kinds of questions by investigating explosive, violent personalities compared with calmer folks. And I've signed up to be one of their crash test dummies.
Do you have this in a 44 long?
Scientists here are doing comprehensive studies on hundreds of volunteers.
300?
Oh, sorry.
Thanks a lot.
They run a battery of tests, analyzing personalities, genetics, and family histories.
Before we start, can you hold my brain?
They're trying to discover how these factors and our environment may impact aggression. I get the 3rd degree in a behavioral analysis called the Buss-Perry Aggression Questionnaire.
What we're going to do is use a scale from 1 to 5, okay?
That's a fancy name for asking really personal questions.
Okay. People often joke about me when I'm not around.
2.
Sometimes I'm so envious. I typically don't agree with others.
1,
I have no
3,
problem letting my friends suddenly get very mad, but it only lasts.
1.
I often feel like a pressure cooker. Pressure cooker. Pressure cooker.
Why do you people always ask me this?
You can see here that it's time.
Luckily, my results show my aggression levels are normal. But sifting through hundreds of profiles, lead investigator Nellie Aaliyah Klein looks for clues to what causes some people to have hair-trigger tempers.
Is there a scale? Is there a Richter scale for anger? Are there specific medical terms for these different degrees?
There are people who intermittently explode. They feel anger on a regular basis, and then when there's a confluence of events that provoke them in certain ways, then they lose control and they explode.
Hey, stop, man! Don't hurt him,
Nellie Aaliyah Klein says this extreme form of anger that we sometimes see on the news is called intermittent explosive disorder, or IED. It's estimated to affect as many as 16 million Americans. And incredibly, Aaliyah Klein can see how IED affects the brains of her test volunteers. She uses PET scans, or positron emission tomography, to measure activity levels in different parts of the brain.
Here on the left,
with these scans, she compares the average activity for 2 groups: people with high levels of aggression, including IED, on the right, and those with low aggression on the left.
We call these blobs. And what they tell us...
That's the technical term?
Is, yes.
Blobs.
And what they tell us is that's where the activity, the brain activity, is happening in these specific regions of the brain.
The more violent brains have big yellow blobs showing increased activity in areas including the premotor cortex, which helps control movement. This area often lights up when we're anxious and perceiving a threat, so we can get ready for action. What's surprising is that the brains of highly aggressive people appear raring to go even when they're not doing anything.
This is at rest. This is when nobody's bothering them, nobody's provoking them.
Wait, so they have this much activity in their brain at rest?
Just at rest. Their brain is more ready for action than the brains of these individuals, the non-aggressive ones.
Well, no kidding. Their brains are going nuts, even when they're just lying there in a tube.
Leah Klein's research reveals that people with intermittent explosive disorder may perceive threats when there really are none. So these folks with violent brains all have the so-called warrior gene? No. Once again, the gene and violence did not go hand in hand. So what else could be influencing these brains? Some studies indicate that in addition to genes, environmental factors, like an abusive childhood, can play a critical role in shaping the developing brain.
One of the things that we know about environments is that environments, too, can change the way that your brain is wired, can change brain structure.
The environment feeds the brain in such a way that it actually changes the brain.
And one of the areas that can be changed by environment is the circuitry involving emotion.
When you have multiple factors interacting, when you have genes that affect this brain circuit, when you have environmental influences that affect this circuit, but also thousands of other genes and thousands of other proteins in the human brain. Those factors together are what push people over and are likely to cause them to be violent.
There's also some encouraging news, evidence suggesting that a positive environment may help counteract negative risk factors.
A positive environment can sort of change the picture, change the future in a way.
Research so far shows that it most often takes genetic and environmental factors to make a violent mind.
What we see is that in people with a certain genetic predisposition for violence or crime, that predisposition may never surface in the face of a positive environment that's able to dampen or mute the genetic effect.
We can't control our genes, but environments can be changed, and that may make a difference. My next stop takes me on one of my most disturbing missions ever. I'm at a special research site at Texas State University, where scientists study what happens to human bodies after they die.
Tell me again why you put dead human bodies in this field.
Well, we're really interested in asking questions about time since death, decomposition, and the best way to do that is to actually simulate a crime scene or a death scene. So that's what we're doing. We need to be careful where we step. There are rattlesnakes out here.
Oh, great. Now we got rattlesnakes.
Now, this is Texas. So there are different kinds of search strategies.
Forensic anthropologist Michelle Hamilton and her team have laid out the remains of people who donated their bodies to help solve some big mysteries. How do different environments affect and alter decomposition? And when confronted with a corpse, how accurately can we determine when someone died?
Here's something. Oh my gosh. Please don't tell me that's hair.
That's hair.
Wow. Is this a he or a she?
This is a she.
And you know that because you guys put her out here. She donated her body and you placed her here.
Exactly. So how long do you think the skeleton has been out here?
Oh, 9 months, a year.
You know, I think 6 months to a year is a good guess when you see a skeleton in this state. But it's wrong. Yeah, this individual 3 days ago was fully fleshed.
3 days? But how could that be? This thing is bleached, dry bones and scattered all around. There's nothing left.
That's what we're going to try to find out.
In a real crime, my mistake could be critical.
Knowing how long it is that a body has been out and decomposing will help us for things like putting a perpetrator at a scene. So timing is really crucial.
They may have an alibi for a specific time, and if our time of death estimate is wrong, then that person may never get caught.
I tentatively placed the time of death at 2 to 4 months ago.
But with the stakes so high, how do experts actually estimate time since death?
She died within the last 12 hours.
On TV, they always make it look so easy.
I estimate time of death at or around 4 days.
To find out how it really works, I'm visiting the Massachusetts office of the Chief Medical Examiner, the state morgue.
What goes on in here?
This is the autopsy suite, and this is where we do all our post-mortem examinations.
Forensic pathologist Peter Cummings performs about 300 autopsies a year, including cases with suspicious circumstances.
This is a typical autopsy station.
In addition to finding the cause of death, it's his job to determine when a person died.
Now, I'm not a forensic pathologist, but I've seen one on TV, and I know that they always go, Your Honor, the time of death was 10:43. So how do they know so precisely when somebody died?
Good writers.
You mean that's not based in reality?
No. I wish we could do that. Majority of my death certificates, unfortunately, I have to put unknown for time of death because I don't know.
What do you mean you don't know?
I don't know.
You always know. They always put time of death 7:22.
I wish. We can estimate, but we can't really get an exact time of death.
All right, so how do you even estimate?
Here, I'll show you.
You want me to get on this
Yes,
thing?
sir. Up.
Isn't this usually reserved for less animated people?
Typically. First thing we'll talk about is rigor mortis. Put your arms up like this, David.
This is how I died?
That's how you died.
I died while I was, using a dowsing rod or something?
Let's think reading in bed.
Okay, it was
reading in bed. Much more peace. All right, so don't let me move you. Try to resist me, okay? So with rigor, what'll happen is your muscles will freeze like this, and I won't be able to move you. What happens is with the body, your muscle contractions are dependent upon energy production.
When we're alive, our muscles move through the interaction of two different proteins. Tiny extensions from one grab and pull on the other over and over again to produce movement. But before the proteins can let go of each other, they need an energy boost from a little molecule called ATP.
So what'll happen when you die, you stop producing ATP, so your muscles can't relax, and they'll stay in the position that you died in if you're left there for a long enough period of time.
Right. It takes about 3 hours after death for the ATP in our muscle cells to get completely used up. And then our muscles begin to lock into place.
So if you've just died and you put your arms down, I'm able to do this to you. If I touch you and you feel warm, you've probably been dead less than 3 hours. And if your body's cold and then flaccid again, I can move you around really easily, I know you've been dead more than 36 hours.
Wait a minute, rigor mortis goes away?
It comes and goes.
Really? I thought you just get stiff and then that's how you are.
No, what happens is your muscles will start to decompose, just like leaving a piece of steak on a counter. It's going to get brown and mushy. Same thing happens to your muscles. So the actual physical fibers break down, and then your rigor mortis goes away.
And as soon as decomposition really gets going, detecting time of death gets a lot trickier. The biggest factor in decomposition is the temperature around the body, especially outdoors.
Unfortunately, people don't always die in their home at a nice room temperature. There are people that die outside on hiking trails, or people that die in water. So the environment and where you die or where your body's disposed of can greatly affect how you decompose.
That's where that Texas field with the body comes into play. TV crime shows call it a body farm.
These are fascinating places. They take humans and do all kinds of things to them to see how they decompose in the environment. What factors affect it? Because there are so many things about a decomposed body that can trick you.
Here at Texas State University, experts like forensic anthropologist Kate Spradley investigate the rate, pattern, and timelines of human decay.
Especially watch your step over.
They've made some surprising discoveries. For one, bodies in Texas decompose faster in the shade than in the sun.
Most of the bodies that we lay out at our facility here in the sun never fully decompose. They mummify.
You're kidding.
And they could do that in about 3 to 4 months.
But in the shade, where there's less light, tissue is consumed more quickly, like on this pig carcass. The culprits come from flies, which land on the body almost immediately and start laying eggs.
So if we come over here and look under the limbs, we might find something here. And lo and behold, this is all eggs.
Oh my gosh.
Literally in the thousands of eggs. So in fact, we could probably pull off some eggs here and give you something to look at. So this is all eggs. You can see they're hatching
it's
right now.
moving!
When the eggs hatch, they become maggots.
It's moving!
And by studying the time it takes to develop from egg to maggot to fly in different environments, investigators can start to estimate time since death. But how do you estimate time of death when there's hardly any body at all? Remember that skeleton I found the other night? I'm told it was a flesh-filled body just 3 days ago. In the light of day, Kate Spradley shows me another skeleton in similar condition.
So what you see right here, the mandible, the lower jaw of the individual we used in our study,
wow.
This was where we placed our body donation.
This is where the body was? Where there's nothing now but a lower jaw?
Where there's nothing now but the lower jaw. And then if you look over here, you can see the bleached white bones, and those are the disarticulated and dispersed skeletal elements.
Incredibly, the bones are now 20 feet from where the body was placed. What could scatter bones and consume a body so quickly? Spradley had to find out.
It was not characteristic of anything that we'd ever seen before.
So she set up a motion-sensing camera and put a pig carcass out to discover what happened. And this is what the camera recorded. Vultures. The fact that vultures can reduce an entire carcass to skin and bones is no surprise. But their speed and efficiency were a revelation to the Texas team.
So it took science to tell us that vultures come and eat dead bodies? Isn't that well known?
It is well known. However, it's not well known how fast they render a human skeleton down to bones.
How long does it take?
It takes about 5 hours.
5 hours? They're like the piranhas of the sky.
Absolutely. It really turns everything that we know on its head. Our study found that vultures can significantly impact a crime scene by throwing off estimations of time since death. They can render a body to a complete skeleton in 5 hours. Normally, it could take, weeks, if not months. That really throws off the estimate of time since death.
Spradley and her team are carefully documenting the vulture evidence, plotting the patterns of how bones scatter in Texas. They hope the database they create will help investigators in real cases recognize the signs of a scavenger attack and avoid drastic mistakes, like estimating that a body has been outside for months when it's only been a few days.
You get angry birds on this thing?
No, you get vultures.
Thanks to outdoor labs like this one, investigators are getting better and better at interpreting the evidence of real crime scenes.
It's very important stuff, and they're starting to collect this data that's going to be very important to me down the road to be able to get that pinpoint number of this person died at 10:22. And that's the point of the science.
Did you plan with anyone to steal that money?
No.
How do you know when criminals are lying?
Did you enter room M1 today?
No.
What goes on in the brain and the body when we don't tell the truth?
Okay, have you ever been inside room M1?
Yes.
Can science detect the signals?
Do you plan to try to lie to me today?
No.
And catch liars in the act? The hope that machines can detect lies goes back nearly a century to the invention of the classic lie detection test, the polygraph.
Polygraph is incredibly controversial. People really don't have soft opinions on it. They either think it's great or they think it is utter hogwash.
So how exactly does this 90-year-old test work? And how trustworthy is it, honestly? To find out, I've come to the National Center for Credibility Assessment, where the CIA and the FBI train all their lie detection experts.
You are now in week 12 of your program.
With the center's permission, I'm going to steal cold, hard cash and then lie about it.
You'll deny you stole anything, deny that you know who took it.
So even though this is a mock crime, the polygraph is still going to work?
The polygraph's still going to work. Our examiner does not know whether or not you are guilty or innocent, and that's his job to figure that out with the polygraph.
Just have a seat, Dave.
Wait, you're going to put me in the electric chair already?
Well, not yet, if you'll...
The whole idea of the polygraph is that lying can cause stress. In that case, my brain would signal my heart and lungs to work faster and harder, and I'd start sweating.
All right, for the purpose of the test, I need you to uncross your legs, put your feet flat on the floor.
Next door, investigator Keith Gaines watches for these changes in me like a hawk.
This records respiration. We have sensors on the chest and on the abdomen that pick up the person's respiration during the test. This middle channel, this is recording perspiration across the surface of the fingers. And then your bottom tracing is blood pressure and pulse rate.
All right, David, what I want to do now is I want to go over the questions with you. They're going to be on the test.
Wait, what? You're going to tell me the questions before the test?
Yes.
Well, doesn't that sort of give me an unfair advantage? I know what's coming.
The purpose for reviewing the test questions is we don't want to surprise the examinee with the test questions themselves, because the mere act of surprise can, in fact, cause reactions.
But that's not what we see on TV and in the movies.
Do you hold a grudge against Montgomery Burns?
No. All right, maybe.
On the screen, questions get asked once, and lies are caught right away.
Good, because I got a hot date tonight. Hot date. Dinner alone.
Not so in the real world.
What we're very concerned with is reactions that occur with the same test question repeatedly over time.
This is the real test?
This is the real test.
Okay.
Did you plan with anyone to steal that money?
No.
Did you steal that money from that wallet?
No.
He's reacting for some reason.
Even though I think I'm doing a great job staying cool and collected, the sensors betray me.
Right here, he was asked, did you take that money out of that wallet?
The yellow line that tracks my sweat response is literally off the chart. The finger sensors seem to have picked up a small amount of sweat, blowing my cover. This time, the polygraph looks like it detected my stress and my lies.
The polygraph is picking up your stress. It's picking up the degree to which you're responding stressfully or it's difficult for you to make an answer. The idea is the more you have to work to tell a lie, the more likely the polygraph is to register the difference from the baseline.
But the polygraph doesn't always work with everyone. Some people, like this serial killer, have no trouble lying during a polygraph. They simply don't react the way most of us do.
Psychopaths don't have those physiological changes when they are lying. The very experience of being interrogated can be very stressful for some and not at all stressful for others.
Innocent people can appear to be lying even if they're just nervous. And that's one reason several states have banned its use as evidence in court. So some scientists are trying to find another way by bypassing the body and going directly to the brain.
We can identify fear pretty readily, but can we identify whether somebody's being deceptive? My goal is to understand what the brain does while we're deceiving.
Jennifer Vendemia and her team at the University of South Carolina are trying to identify deception at its very source. All of a sudden, I'm a melon. And today, the brain going under her microscope is mine.
So what we're gonna do is we're gonna get a picture of what David's brain looks like when he lies and when he tells the truth.
That picture will come from this net of 128 electrodes.
This is the torture part.
Each one picks up tiny electrical impulses coming from my brain cells. Brain cells communicate with one another by firing off tiny chemical and electrical signals in rhythmic pulses. When enough brain cells fire at once, the electrodes can pick up their pulses in the form of brain waves.
Is this an eBay hair salon purchase here?
To get the best readout, Vendemia must carefully map the electrodes by taking a picture of my head as I sit inside this weird contraption.
It's like, Captain, I sense a disturbance in the tri-delta vector.
Go ahead and hold very still for me.
Finally, I'm ready to do some lying. Sitting as still as possible, I read statements on a computer screen. Then I have to press a button, declaring the statement either true or false.
During this study, you're going to see sentences presented in the color red and sentences presented in the color blue. When the sentence is red, I want you to lie. And when it's blue, I want you to tell the truth.
As I ponder each question and figure out how I'm going to respond, Vendemia scours my brainwaves in this color-coded circular map.
You would think that when we're looking for deception, we're trying to find one moment of deception, one moment in the brain where the lie happens. But really, we build the lie over time.
In the split second my brain is deciding whether or not to lie, Vendemia hunts for a particular kind of brainwave called the P300 that shows up as red blotches on her graph.
The P300 is the result of any decision-making process. When a task is really easy, every process that results in the P300 kind of comes to closure all at once.
The P300 brainwave fires when I make a clear and confident decision.
This is about 200 milliseconds before he responds to us. This picture on the right, the truth-telling picture, all these red areas indicate that the process is done. In about 200 more milliseconds, he's going to tell us the truth.
Whenever I decide to tell the truth, red blotches burst out across my brain map, even before I push the button to give my answer. But whenever I decide to lie, my brain seems to struggle a bit more. The different areas involved in the decision take a fraction of a second longer, and the red P300 often doesn't show up at all.
On the left, he still has more processing to do before he's going to be ready to lie. It takes longer to lie because more processes are involved in deception. It's just harder to tell a lie than to tell the truth.
Vendemia sees the same distinctive patterns with her other subjects. She says she can tell when a brain is coming to a quick and easy decision to tell the truth.
On the right is truth.
And when it's working a little harder, to lie.
On the left is lying.
You got to the point where you could look at the data and without seeing what the question was, know whether I was lying or not.
Yes.
You got to that point?
Yes, absolutely. In fact, we got to that point with about 85.3% accuracy for you.
That's freaky.
This research is still very preliminary, and it hasn't been tested on psychopaths and others who may be able to fool traditional lie detection tests. Still, if lie detection is going to move forward, there's a good chance it will be in this direction, probing the mind in more profound ways and threatening the idea that our thoughts are exclusively our own.
It is a bit terrifying because we all believe that our brains are safe, that our thoughts are safe, that we have something that we might call mental privacy. And the idea that I only share that which I want to share may simply be a nice, antiquated idea of the past.
resist the golden lasso. It compels them to tell the truth.
A new kind of criminal activity is on the rise, thanks to computers. It's cybercrime, and Yoshi Kono has mastered its tools.
It's being called a security breach of staggering proportions.
Yoshi could hack anything. If a bank says, our site is secure, in my head I'm always like, no, it's not. Yoshi could get into it.
A pack of cyber thieves allegedly managed to infect computers at NASA, Netflix, iTunes.
He comes up with the most creative attacks and the most scary things you could imagine.
Yoshi has hacked into cars, voting machines,
even worse, the fear that an election could be hacked,
and medical devices.
Somebody could remotely amp up a heart device. Hacking can literally become a matter of life and death.
These days, we're surrounded by computerized and networked devices. Yoshi sees each one as a potential doorway that he can break down and then take control of what's inside.
The fact that everything has a computer in it is really alarming from a security point of view. And the fact that those computers are all generally on networks is even more so.
The comment that people mostly say is, thank goodness Yoshi's on our side.
Yoshi is a computer hacker. But lucky for us, he works for the good guys.
Jokingly amongst the lab, we say, we're trying to save the world.
As a security expert at the University of Washington, he's on the front lines of the fight against cybercrime.
Our privacy is slowly eroding over time, and we need to either make a conscious decision to let it continue to happen or try to stop it.
When we share some of Yoshi's research with friends or family, they're like, oh my God, I never would have thought about that. Where does Yoshi get these ideas?
As part of his strategy, he's constantly trying to get into the heads of the bad guys.
This is the ability to see the world the way an adversary might see the world.
And if you look at the world this way, you're going to find weaknesses in the security armor everywhere. Even in the etched glass of an office door, designed to prevent people from seeing in.
As a security person, the first question that came to my mind was, well, does it really work and is it possible to see through?
Yoshi knew that the jagged surface of the glass was bending the light, making it hard to see through. If he could find a way to smooth the surface, he would be able to spy on someone.
This was, as simple as actually putting honey on the surface of the glass.
And just like that, with a drop of honey and a smooth layer of glass, Yoshi figured out how to straighten the light, make the glass transparent, and perhaps invade someone's privacy.
This is a perfect example of how just looking at the world in a slightly different way, you can uncover potential privacy or security issues.
By all accounts, Yoshi has been looking at the world this way for most of his life.
I think I learned a lot about security and privacy in the real world from my parents. The need to always lock the door, the need to be cautious about, how you walk when you go off to school.
Yoshi was a computer whiz from a young age.
On the side, you see you're entering the world of cyberpunks, hackers, freakers, and programmers. Beware.
He was fascinated by cryptograms, an old spy technique of creating secret codes.
I was intrigued by cryptography because it had an element of kind of adversarial tension between me and the person who made this cryptogram. Can I figure out what they did to try to make this message secret so that I could try to solve it?
Today, Yoshi leads a team of young security experts who are trying to outsmart their adversaries, any potential computer hackers with ill intent.
It's always an arms race. You're trying to stay one step ahead of the criminals, and the criminals will try to stay one step ahead of you.
Yoshi's team has the know-how to hack into pretty much any machine that broadcasts or receives digital information wirelessly. Yoshi believes if it's connected to the outside world, then there's no such thing as an unhackable computer. Like the Nike Plus iPod Sport Kit, a gadget designed for runners to put in their shoes to help track their speed and distance.
And it really was an example of a technology that pervades our life in different ways than a traditional laptop or a desktop.
Yoshi figured out how to hack into the signals sent out by this tiny transmitter and keep tabs on anyone wearing the device.
There she is. I see her, the sensor on my laptop.
And the news took notice.
It's one of Time Magazine's Gadgets of the Year.
But it also has a serious security problem that could leave innocent users vulnerable to invasions of their personal privacy.
But Yoshi's goal isn't to make us all paranoid. Instead, he wants the makers of these devices to plug their security holes before they go on the market. Even if you don't have the sport kit, there's a good chance you're carrying around something else that could compromise your personal data without your knowing it. New generations of passport cards and enhanced driver's licenses have computer chips that Yoshi and his team have been able to read, some up to 50 yards away.
We as consumers need to be aware that our privacy is being exposed by the technologies we have on our bodies and around us.
And it's not just your privacy that Yoshi is trying to defend. If a machine is controlled by a computer and connected to a network, then hackers could potentially take over the reins. Even a machine as complex as a car.
The car project was one of these examples where we look at an existing on-the-market device to see if it's vulnerable to attack. Essentially, could we hack the car and control it remotely?
You might not realize it, but if you drive a car made in the last few years, it's full of computer software.
We have computers controlling the brakes, the steering, the door locks.
You can also order some cars with built-in cell phone systems designed to connect to operators in an emergency.
There are cars that can call 911 for you if you get in an accident.
Yoshi saw the car's cell phone as another potential security hole, one that could serve as a portal to a vehicle's computer system to be exploited by a cyber car thief.
If someone else can use that remote connection to do security attacks, it makes you a lot more vulnerable.
Yoshi and his team set out to hack into one of those cars, so the first thing they do is buy one. They want to see if their car's phone can give them a direct line to its computer system. Their fear is that an evil hacker could set up a computer to call thousands of random numbers to locate and then take control of a car.
There's that number. Ready to dial it? Sure. Okay. Dialing the number.
Once they have the car's number, they call it, hoping they'll be able to install their own software over the phone line and onto the car's computer.
The sound is going to come over those headphones, play into the phone. That's going to get received by the car. All right, and send. All right, went through successfully. Awesome.
Now they could have the car report its GPS location, and they send the coordinates to Yoshi, who stands in as a thief.
Hello?
Hi, Yoshi. We've got a car for you that we're going to unlock.
Ah, great.
And we're going to flash the lights so that you can find it.
Now that they have a direct line to the car's computers, they want to see if they can take control and make the vehicle think that someone is flashing the lights.
Okay, flashing lights now.
Let me see. Flashing lights, flashing lights. Yeah, oh, I see the vehicle. Okay, and I'm walking up to it now.
But could they unlock the doors and start the engine?
Now we're going to initiate the unlock sequence. The car should unlock and the engine should start.
Okay, the car is on. Getting in the car. And I'm going to start driving. Here I am driving.
Yoshi's team took over the car from an office a few blocks away. But with this technique, they could theoretically do it from almost anywhere in the world using a wireless connection.
What really surprised us was how easy it was to do these things. We could take over almost anything in the car that was electronically controlled.
And these days, even your brakes are electronically controlled. Does that mean Yoshi could hack into a car's brakes?
Okay, so Alexi, you'll be in the driver's seat and we'll be up in the bleachers.
The team takes a car to a closed track to find out.
Okay, ready? Okay, Alexi, we've unlocked the brake controller. And just to verify, you have your helmet on and all of the safety precautions in place, right?
That's right, helmet on, gloves on, strapped in, ready to go.
Great, okay, go ahead and go. And we will apply your brakes when you get to the checkered flag area.
By sending their malicious code to the car, could Yoshi trick it into jamming on the brakes?
It is a very scary thought that you're driving in a car and some kid could be messing with you just for fun.
And we'll be applying your brakes shortly. Right about now. Ooh. Yeah, that worked. Ooh, is he gonna go to the wall?
That was kind of close. Just do the right brake. Wow, okay, that worked.
What Yoshi can do looks pretty scary, but it's the result of months of painstaking research by the sharpest minds in the security business.
We don't believe that there are hackers out there attacking today's cars. Our goal really is to show that these kind of attacks are possible so that the manufacturers of the cars and the government and the various policy organizations take it seriously for the next generation of cars.
Yoshi is one of our most vigilant guards against cybercrime. He's consulted with government and industry, even companies like Microsoft, pushing them to examine things like car security, electronic voting, and the safety of implantable medical devices.
Yoshi's goal is to secure the future, to make the world a safer place.
I really do want to understand how can we protect the security of future technologies so that when my kids are my age, they're in an environment where technologies are safe, reliable, secure.
So Yoshi will continue to hunt down the holes, the weaknesses all around us, conquering the criminals by outwitting them at their own game long before they can make their move.
He has all sorts of devious thoughts that would be pretty harmful if he was on the wrong side of the law.
We thank our lucky stars that Yoshi is on the side of the good guys.
It's a good thing, because when Yoshi looks at the world, he sees a lot of hacking left to do.
You see computers in transportation systems, stoplights, our power distribution grids, the sewage and water lines, airplanes. There's computers everywhere, and I think we've only begun to scratch the surface.
And now it's time to put you on the case. Follow us on Facebook or Twitter, or log onto our website and tell us what you think. You can see any of these stories again, you can watch exclusive short web videos, you can hear from our experts, or you can check out our web-only series, The Secret Life of Scientists and Engineers. You can find it all at pbs.org/Nova Science Now. Vultures! The vultures! They're coming!
Funding for Nova Science Now is provided by the National Science Foundation, where discoveries begin. And
discovering new knowledge. Biomedical research and science education. Howard Hughes Medical Institute. HHMI.
and the Alfred P. Sloan Foundation, supporting original research and public understanding of science, technology, engineering, and mathematics, and the George D. Smith Fund. And by PBS viewers like you. Thank you.
Little stirs in an Arctic winter, apart from the snowy owl. This is no place to raise a family, but two intrepid parents will try to do just that. And how it's done is the snowy owl's greatest trick.
This Nova Science Now program is available on DVD. To order, visit shoppbs.org or call 1-800-PLAY-PBS. Nova is also available for download on iTunes.
Is there any way science can stop crime? I'm David Pogue, and on this episode of Nova Science Now, we're tracking down cutting-edge research in the world of crime fighting. Are killers born or made?
These stories started to proliferate that there was something really wrong in our family.
Are some people more prone to violence than others?
What is the warrior gene, and what is its relationship to aggression?
There are some men that are biologically speaking much more likely to be violent and aggressive than others.
we're peering inside the criminal mind.
Environments can change the way that your brain is wired.
And
Captain, I sense a disturbance in the tri-delta vector.
with new technology, can we sense lies in the brain before they're even spoken?
In about 200 more milliseconds, he's going to be ready to lie.
You got to the point where you could know whether I was lying or not.
Yes.
That's freaky.
And can scientists help investigators determine when a victim died?
So timing is really crucial.
How do you even estimate? Here, I'll show you. Isn't this usually reserved for less animated people?
Typically. Their discoveries may shock you.
3 days? But how could that be? That's what we're going to try to find out.
Can science stop crime? Up next on Nova Science Now.
Funding for Nova Science Now is provided by the National Science Foundation, where discoveries begin, and
Discovering New Knowledge. Biomedical Research and Science Education. Howard Hughes Medical Institute. HHMI.
and the Alfred P. Sloan Foundation, supporting original research and public understanding of science, technology, engineering, and mathematics, and the George D. Smith Fund. And by PBS viewers like you. Thank you.
I'm David Pogue, host of Nova Science Now by day, and by night, a Caped Crusader.